Hello, Logic Up people, logical people. Welcome back to my channel called Logic Up. The purpose of my channel is to cause people to think. Okay, use logic to try to figure things out, and you may not be able to be correct, but if you keep using logic, eventually you will be. And logic must be based on evidence if possible, and patterns of things. Okay. So the subject for today is this is an exercise in logic. Okay, you don't have to agree with it, but it's gonna blow your mind because this is something that nobody ever mentions. Okay, not even scientists, and I don't know why, or at least I couldn't find it anywhere that talks about it. So I came up with the idea on my own, which some people think, well, it's not legitimate because you're not a scientist. No, I'm not a degreed scientist, but everyone can be a scientist. In fact, all kids are scientists. The criteria for being a scientist is you have to be curious, and you have to be open-minded, and you have to be able to formulate your theory or your hypothesis based on evidence. Okay, science is all about evidence. It's not about opinion. Okay, you can have imagination, to come up with hypotheses to explanations, but if you want that explanation to really truly explain what nature is, you have to back it up with evidence. And that's why scientists conduct experiments, to try to verify. Okay, here's an exercise in logic, okay, for you. Although I have not conducted any experiments, and I think somebody should. Okay, the subject for today: why or how is it that dinosaurs became so big? Okay, prehistoric animals. All right, ever wonder how prehistoric animals became so big? Okay, well, a lot of scientists have explained that, well, the reason dinosaurs were so big back then was because of the plentifulness of food, right? Obviously, there were no people back then. At least that's the current theory. There were no 8 billion people around the planet back then. So we couldn't have used up all the resources. Therefore, there are a lot more food for them to eat and things like that. But I don't think so. Because back then there were dinosaurs. They roamed the earth. I mean, they're bigger. They eat more. They eat more than humans. So no, it's not that. And if once I explain this to you, if you're objective, okay, if you're not objective like most people are, they just dismiss it because it's something new they never heard of, and that's why they dismiss it. That's one thing I find out about people, is that whenever you present a new theory, a new hypothesis, 9 out of 10 times, in fact 10 out of 10 times, they dismiss it just because it's new, just because they never heard of it. They don't use logic to say, wait a minute, you got something there, maybe there's something there, maybe there is something there. Okay, they don't think that way. They dismiss it outright because they never heard of it, they never read it anywhere, no authority told them, no Harvard study or a politician that they trust, right? That's not science, is it? Science is about evidence. All right, no matter how wild the theory is, and there are a lot of things in science, in nature, that are extremely wild, man. Only if people know. Okay, one of which is quantum mechanics. Okay, but that's I'm getting that's a subject of another video. Okay, so back to the question: how is it that dinosaurs back then, 65 million years ago, became so big? What mechanism that caused them, that would allow them to become so big? And oh, by the way, ever since then, no land animals on Earth could become that big, could get that big. Now that's a clue right there. Okay, so whatever mechanism, use logic now, logic up, use logic. Whatever mechanism that allowed the dinosaurs to become so big back then obviously doesn't exist anymore. Otherwise, today's animals could still be that big, right? They say, well, they're reptiles. Well, why can't reptiles evolve to be that big? if the conditions are right, they will get that big. There's no difference just because back then it's older. No, if we have the same conditions today, it's going to allow them to be as big. Okay, now, so are you ready for this? Are you ready for my theory or my hypothesis? It's not even theory, because theory has to be supported by evidence too. Hypothesis is something that you propose, okay, and hadn't been tested at all. So it's very raw. It's very, it's just an idea thrown out there. Okay, so don't get overexcited. But I think it grants some studies, okay, by degreed scientists who know how to conduct these studies to find out, to verify if it's true or not. Okay, here's my theory of why dinosaurs were so big and no earth animals, okay, no land animals on earth could ever become that big again since then. Here's why. The reason why is because the earth used to be smaller than it is now. A smaller earth meant less gravity. Less gravity meant that animals can grow bigger because they don't have the gravity to pull them back down. Okay? Now, what kind of support do I have to claim that? Right? Because like I said, everything has to have evidence, right? Curiosity, okay? You can't just say something, totally illogical, totally out there, and then expect, any support for the study of it, to, at least to find out, is that true? Okay. Here are the evidence, okay? And these things actually baffle scientists. They can't explain it, but yet if the Earth was smaller, then that could explain why. First example, Brontosaurus. Okay, Brontosaurus, right? A Brontosaurus looks like, it has really long neck. It's a big animal. Okay, has really long neck, a big body, and really long tail. Okay. And you've seen drawings of them always in the water, in the mud, right? They're always in the water, and the drawing, because paleontologists, when they dig up the bones of these animals, these Brontosaurus, it always showed evidence that it's in water, it's in mud, because of maybe the shells and things like that. So it suggests that it's in the water. So then they say, oh, okay, well, these things are so big that they have to always be in the water. I guess the water provides some buoyancy, but to cool them off. And then they have a very long neck that they reach up high to eat leaves on high trees. Okay. Well, scientists are baffled because if you look at the neck of those dinosaurs, it's very long. Okay, it is so long. Okay, several stories high in building. Okay, it is so long that scientists are baffled how the dinosaur could have pumped blood all the way up to its head. Its heart has to be as big as the chest cavity itself. Obviously, dinosaurs have other organs in their chest besides the heart. And if the heart gets too big, then of course it's too heavy and all that stuff. And also, here's another problem. Let's say the heart of the Brontosaurus is that big. Well, if it is that big, it has to pump very, very powerfully, right? Well, if it pump powerfully, then it will cause the dinosaur to have a stroke every time the dinosaur, the Brontosaurus head reaches up high to eat something, right? It goes vertical. So then more blood has to be pumped up very, very quickly. When that happens, it will burst the vessels inside the neck or inside the head of the dinosaur, because the head is very small. And, their blood vessels would be a lot smaller, right? So you have the main artery that goes up, main few arteries, I'm sure, that goes up, that went up the neck. And then you have little capillaries, and little blood vessels that's in the brain of the dinosaur, right? They will all be burst because the pressure would be too high, So how did the dinosaur survive? Some scientists suggest that, well, maybe the Brontosaurus has two hearts. The main one is in the chest, and then a smaller one halfway or some way up the neck. Okay, so then the main heart pumps the blood up, and then the secondary heart pump the rest of the blood up to the head, to the brain. The problem with that is they find no evidence of that. When they look at the bone structure of the neck of the dinosaur, there's no indentation or pocket of anything, that shows that there used to be some organ, a heart there. They found none. So then, okay, how did they, how did the blood get up there? Okay, without causing a stroke. Okay, unless the Earth was smaller, there's less gravity, therefore it takes less power effort to get the blood up to the head. You see that? That could explain why or how the brontosaurus got so big without having a stroke and die. Okay, that's one evidence. Okay, the second evidence lies in flying dinosaurs. Okay, you call them pterodactyls. They're called pterodactyls. Okay, dinosaurs that flew back then. They actually flew. Okay, and some of these pterodactyls were the size of today's giraffe. And you know how big today's giraffe are, right? They're like 5-story high neck or something like that. All right, they're very tall. They're very big. Okay, look up for the size of today's giraffe, and you see how big they are. Okay, they're huge. All right, a bird, a flying animal the size of a giraffe simply cannot take off. It'd be too heavy. Even with the hollow bones, of birds, right? They calculated that not only that it doesn't make sense that such a big animal could actually take off under its own power because it's so heavy, but secondly, the power required, the chest muscles have to be enormously powerful, for it to flap its wing powerfully enough to lift itself off the ground. Okay, some people might suggest, well, these pterodactyls didn't really fly, they just glide off a cliff, right? They just glide off the cliff. They run, right? They spread their wings, they run, and then they just jump off a cliff, and that's how they fly. Could be, but then when they look at the archaeological evidence, they found that, they pieced back together the evidence of the location, that, well, this location was not a hill, or was not a mountain back then. Okay, so how do you explain that, right? Another way to explain that would be the Earth was smaller. It had less gravity back then, so therefore, it allows flying animals the size of today's giraffe to fly. Okay, now, third evidence, okay, is probability, right? We learned that, the prevailing theory today of how the dinosaurs vanished was that they vanished because of an asteroid. A huge asteroid hit the Earth about 65 million years ago. It caused a fallout, kind of like a nuclear fallout. The dust, it kicked up the dust and Earth into the atmosphere, cover the sky, and block out all the sun for millennium, for probably millions of years. And so they didn't have the sun, the plants die, the animals that eat the plants die, the dinosaurs die, and that's how the dinosaurs became extinct. Okay? If one asteroid, how did they know if it's not more than one asteroid that hit Earth? In fact, in the early days of the formation of the solar system, there were a lot of collisions, right, of planets and moons. Look at our moon. Okay, look at the surface of our moon. How many craters there are? Okay, the Earth would have looked the same if the Earth didn't have the weather, right? It's weathering on Earth. The weather erased the evidence of the collisions. Okay, even so, based on satellite images, scientists think they found the asteroid, the crater that made the crater that destroyed the dinosaurs. Okay, it's located in Mexico, in today's Mexico, and the crater is humongous. Okay, you can't see it on Earth. You can't see it from ground level. You have to go up into space to look down and to see it. Okay. So they think they found evidence that particular asteroid was big enough. But there were many asteroids and meteors and meteorites and rocks from space, even ice rocks called comets. Right, comets are ice rocks. Right, that hit Earth throughout Earth's history. Okay, you look at, for example, the orbit between Mars and Jupiter. You know where that what resides there? It's the asteroid field. Okay, it's full of rocks. Okay, that's floating in space in an orbit around in between Mars and Jupiter. Okay, what was there before? Those rocks now, the asteroids, are remnants of a planet that used to be there. All right, something hit that planet. Okay, and broke it up into millions of pieces of what we call asteroids. Okay, they range from the size of mountains, okay, to smaller size, like the size of a car, I guess. And so they orbit around, that area between Mars and Jupiter. So that's evidence right there that there were collisions back then. Now, some of those asteroids, rocks that resulted from the collision, got thrown off that orbit and showered the Earth, right? Got into Earth's orbit, and when the Earth comes around, some might hit the Earth. Some did hit the Earth and kill the dinosaurs. See? So then, what happens to the matter of those asteroids? They added to the Earth's matter, right? Added to the Earth's mass, right? You don't just drop onto the Earth and then the matter doesn't add to the Earth, right? Now, if it's a small rock, then of course that's negligible. But we're talking probably thousands, if not millions, of rocks the size of the mountain. Seriously. It's the size of mountains, okay? Hitting the Earth. So, of course, it adds to a little bit to the size of the Earth. So, just enough. See, not only it destroys the dinosaurs, okay, or they destroy the dinosaurs, but they add to the mass of the Earth. So then any other animal that evolved after the dinosaurs could not get that big, except ocean animals, right? The blue whale is the biggest animal on Earth, not the dinosaurs. Blue whales are bigger than dinosaurs. But how they get that big? Because they're in the water. Water has a lot of buoyancy, right? In the ocean. And so the buoyancy kind of negate gravity a little bit, right? It reduced the gravity. So therefore allows the whales to be big, humongous, right? But that's the only exception. Any land animals cannot grow as big as dinosaurs anymore after the dinosaurs all died out 65 million years ago. So that's the mechanism, okay? That is the mechanism that limit the size of dinosaurs after 65 million years ago. And that mechanism is, namely, the size of the Earth, the gravity. You see that? So that's an explanation right there. Now, any scientists out there, degreed scientists, can study this, can look at the evidence. Okay, it's easy. You can look at the evidence and infer from it. For example, you look at the moon. Study the moon. How many craters are there on the moon? All right, count how many craters, and then estimate using algorithm how many craters on Earth. Okay. So then with that, based on the size of the craters, all right, and look at the evidence based on satellite images around the world, look for remnants of craters, and then you calculate, okay, the Earth had around this many craters hit it, and this many objects hit it, and that's why you have this many craters. Obviously the moon has less craters than Earth simply because of its size. Think about it, right? The bigger the target, the more likely it's going to get hit. Okay, so the moon is smaller and it has that many craters. The Earth likely has a lot more craters than that. Okay, so with all the craters that were produced by all these objects, these heavenly objects that hit it, asteroids, meteors, and things like that, space rocks that hit it, it accumulates. It increased the mass of the Earth a little bit. A little bit, enough that animals on Earth, land animals, can't grow any bigger anymore. The biggest land animal, I think, is an elephant, right? An African elephant. An African elephant is the biggest. You can't grow any bigger than that anymore. Okay, so that's one way. I'm sure scientists, degreed scientists, really smart guys, they can come up with, guys and gals nowadays, they can come up with other ways to measure. So with that, thank you, and we'll see you next time.